Okay, so let us go to the next test part, 12L. This is the last numerical test for chapter 12 electricity, class 10, okay? Question number 21 on page 233. So let me read the question for us. Two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt, are connected in parallel to electric main supply. What current is drawn from the line if the supply voltage is 220 volt? So first two lamp, let us write here as we read the question. Looking to the question, you can write for the first lamp, means electric bulb only lamp, rated according to textbook language 100 watt. Let us put this one as power, watt is power, so P1, at 220 volt, the question is saying. So this is the voltage V. So for this, let R1, let us put is equal to question mark, is its resistance for the first lamp. And let us find it out. See here, the power equations that we have been using, the four main power equation is power is equal to NRG E or W by T, P is equal to V into I, P is equal to I square R, P is equal to V square by R. The four main power equations. Which one to find R? So V is there, P, R, VPR, VPR. I think this is the right formula. So let us write here, since we know P is equal to V square by R, and we're using P as P1, so put your P1, R is R1, V is same V. So with this we can find out the R1. So you can bring that up, then we are going to get here P1 into this denominator will go up, V square. So R1, don't shift that, V square divided by this P1 will come down, because we want to find this R1. Okay, so R1. So if you were to put the right values, then V is here 220, so 220 volt into again 220 volt, because V square, so 2 times we have to write P1 is, as you can see here, 100 watt. So 1, 2, 1, 2. 22 into 22, multiply this 484. So 484, and SI unit of resistance we know is ohms. In other words, volt into volt divided by watt is. Everything is in SI unit here, so the SI unit is the resistance. The resistance also will come under in its SI unit ohms. So this is 48, and this one. So let us, R1 is put here 1, equation 1, let us see. Similarly, for the second lamp, there's two lamps, right? For the second lamp, as we read the question, rated, according to question, rated 60 watt. Let us put this one as P2, because watt is the power, at 220 volts. Again, 220 volts, so the voltage is the same V. Let, in this case, the resistance will be different, so R2 equal to question mark is its resistance. So we wrote here similarly like we did for the first case. So directly we can avoid these two steps and go here. R2, this one will be like this one, V is same, so V squared by P1. Now we are going to use P2. So we're able to skip these two steps because we have put here similarly. So V2, meaning in the same way we did for the first one, that's what we mean. 220 volt divided by P2 is 60 watt. So like this. So once we're through with this, these two will cancel off. 2 3s are 6, and then 2 into 11. I think no more is going, so 220 multiplied to 11. 2 2 2 2 2 4 2 and one more 0. So when we multiply this 2 4 20 divided by 3, SI unit of resistance again, ohm. Let's put this one as equation 2. We have 1 and 2 now. So question, go back to question and see what is the question asking us. Question is saying what is the current from the supply if the voltage is 220 volt. So in order to get current, I think we're going to have to use Ohm's law. So V is already there, say 220 volt, I into R. We need to find this, so R, total R we need to get. So they are in, and the two lamps are connected in parallel. So as you look into the question, we see the two lamps are connected in parallel, okay, in parallel. So let RP be the total resistance which are in parallel. Now if they are in parallel, the formula is reciprocal of total 1 by RP equal to 1 by R1 plus, in the second case, R2, R1 and R2. So we have to use the parallel formula. So we write here, that implies 1 by RP, 1 by R1 here, 484 ohms in the denominator plus long line, okay, 1 divided by R2 here, 2420 divided by, make this one longer, by 3, and ohm should be in the denominator. And right here, since using equations 1 and 2, we put R1 value from equation 1 and R2 value from equation number 2. Okay, so we can just rub it out, this one. No, it's fine. Now next here, that implies 1 by RP will be 1 by 484 ohms. Please note that ohm should be in the denominator, plus 1 into means down denominator 3 will go up, and 2420 along with the ohm will come down. Down will go up will come down when you change this long line division into multiplication sign. So that's what we're getting, 3 by 2420 ohms. So next step, that implies 1 by RP will be equal to here 484 and 3, 2420 LCM is, I think it is this one. LCM is 2420 ohms, because 484 into 5 is going, is a multiple. This is a the bigger number is a multiple of the smaller. Check it, 4 5s are 20, 5 4s are 20, 5 8s are 40, 42, 5 4s are 20, 24, 2420, exactly. 484 into 5 is 2420, which means the bigger number 2420 is a multiple of the smaller 484. Then the bigger automatically becomes the LCM, meaning when two numbers are there and the bigger number is a multiple of the smaller number like this, then the bigger number automatically becomes the LCM of the two. So 484 into 5, as we see, is equal to 2420. So 5 into 1 will be 5 plus 2420 denominator into 1 is 2420, the LCM. So 1 into 3 will be 3. So 1 by RP is 5 plus 3 is 8 divided by 2420 ohms. Go about it slowly. Okay, so here I think 4 is going, so 4 2s are 8, 4 6 are 24, no remainder, then 2 is less than 8 because we have to take one digit at a time, so we have to put 0 first, then only we can combine this 20. 4 5s are 20, 605. So if we cross multiply, then as you look into the question, we're going to get here RP into 2 is 2 RP is equal to 605 into 1 is 605 along with the ohm. So the total resistance value Rp is 605 and this 2 will come down ohms. Let us put this one as equation number 3. And finally look back into the question. What is the question asking? What current is drawn? So let's just write in the same fashion. One way to do it easily is what current, so let's just write like question. What current, let us put here current I, okay, is drawn according to the exact language of the text. Drawn if supply voltage is 220 volts. Let's put this one as V. The question is this one. So we know V is there, I and Rp we just got now, so we can easily now use Ohm's law. By Ohm's law, V is equal to I into R. V is okay, I we're using I, R is we're going to use the total, Rp because they're in parallel, right? So now, what current? So we have to find I. So just put I, don't move, V divided by Rp will come to the denominator. So V is 220 volt, as we can clearly see here. Rp value is here 605, longer line, 605 divided by 2 ohms is equal to I. Do go about it slowly. Let us go. And we write here, since using equation number 3 to put this value of Rp equal to 605 by 2 this here. Just a matter of solving patiently. So here 220, just write that. And the longest line here means divided by. If we change it to multiplication, then numerator denominator will go up, 2 will go up. And numerator up, 605 ohms will come down along with the ohms. So this part dealt 220 into this 2 will go up, 605 ohms will come down. It's like this, equal to I value. So now it's just a matter of cancelling, I think. So 5 is going, 5 ones are 5, 1 in hand, 5 twos are 10, 1s are 5, 5 4s are 20, 2 in hand, 5 4s are 20. So 11 is going again, 11 ones are 11, 1 in hand, 11 ones are 11, 11 4s are 44. No more is going, I think. So 8 by 11, 4 twos are 220 volt. Okay, instead of putting ohms and all these things, so we can write here a slight correction, 220 volts, cancel. Okay, now we know volt by ohms is ampere. 4 twos are 8 divided by 11. Volt by ohm is ampere, the SI unit of current I. So that will be equal to 8 divided by 11. So 0 point, because 8 is less than 11, then 1 0, 11 7s are 77, 3 remainder, the 0 can come because of this decimal, 2s are 22, then 8 in hand, 0, so 11 7s are 77. Up to third place we can go, so we're going to get 0.727 ampere is the I value. So this is 0.7. Third place is 5 or more than 5, and the second place will increase by 1, so 2 will become 3 ampere. So the current flowing is 0.73 ampere approximately. We'll do the next 22 and 23 in the next class, after which you can take the test. Okay.